Assalamu alaikum. This is the third lecture of the online lecture series for Geotechnical Engineering 1. Course code is CE221. And we start with the name of Allah. Rabbi shrah li sadri, that means my Lord expand my chest. And once again I want to give you a reminder that we should remember this dua that will help us in increasing our learning capacity. May Allah help us all. So starting with today's lecture, so we will first talk about the types of clay deposits. So especially when we talk about cohesive soils and specifically about clays, so it is important to remember that clays have memories. That means they would remember that how much load they have experienced in their past. In the current situation, there might not be any load on top of the clay layer, but if it were loaded maybe centuries before, and due to some reason that load was removed, but the clay layer would remember that loading. So that's why we say that it has a memory. So in the natural process of deposition, fine-grained soils like silts and clays, they undergo process of consolidation under their own weight of overburden pressure. So what is meant by this is that if I draw a ground surface here, okay, and so this is the clay layer. So if I want, maybe this is the total thickness of the clay layer, let's say that is 10 feet, okay. So if at the center of the clay layer I want to see that how much is the overburden, so I will simply find that by gamma into H, where gamma is the unit weight of the clay, and H is the height up to which I am measuring the overburden pressure. So sigma naught, that is overburden pressure, is simply gamma into H. So if I draw that sigma naught overburden, so it will be plotted like this. If this is a straight line, so overburden at the top would be 0 because gamma into 0 would be 0, and with depth, so you see it's a linear distribution. So at any depth you can find out gamma into H, so it increases from top to bottom. So this is the self weight or the overburden of the soil that is causing it to consolidate. So a state of equilibrium is reached after a lapse of several years and the compression ceases. This process continues season after season, and sometimes erosion or removal of the overburden takes place, and sometimes the process of consolidation may be continuously taking place due to frequent deposition. So it is evident that clay soil deposits exist in the field under different conditions and their stress history should be known. So for instance, if this clay deposit was placed recently, so it will consolidate under its own weight, okay, but obviously depending on the permeability it will take some time. So whenever we're going to do construction, it will depend that in what phase the soil currently is, because that will change its behavior drastically. We'll see further definitions to further explain this concept of self-weight loading in consolidation. So first thing first, we have this definition that is normally consolidated soil or normally consolidated clays. So if the present effective overburden pressure in the deposit is maximum pressure to which the soil has been consolidated at any time in the past, such a deposit is called as a normally consolidated clay deposit. So there is no actual procedure to predict the in situ effective void ratio relationship, okay. So to explain this, if I draw, so if this is the ground surface and you are going to do a construction work here, and this here is the clay layer. So this, let's say it's sand. So I want to know that what is the current overburden pressure on top of the clay layer. So I will find out here. So if gamma S is sand unit weight, and H1 is thickness of the sand, and H2 is thickness of the clay layer, and gamma C is the, let's say gamma C is the unit weight of the clay. So sigma naught at the current time when you are going to investigate or when you are planning to construct would be equal to gamma S of sand into H1, that is height of the sand, plus gamma clay into H2 by 2, because we are finding the overburden pressure at the center of the clay layer. So this is the current overburden pressure sigma naught. Now there is one thing or that is actually the property of the clay. Okay, if I take a soil sample out of it, so I can find out PC, or we call that as pre-consolidation pressure. So we will learn in a while that how to find out PC for a certain soil sample or a pre-consolidation pressure. But if the two values, that is this PC is also indicated as sigma C, so it's your choice whatever you want to adopt. So if sigma naught, that is current situation or the current overburden pressure, is sigma C is equal, then we call that as normally consolidated soil, and that means that soil has not been loaded more than the current overburden pressure in the past. Then we have the second type, that is the over consolidated soil. So a clay deposit that has been fully consolidated under pressure PC in the past, larger than the present overburden pressure, okay, over P naught, is called as an over consolidated clay deposit. The ratio PC minus P naught or P naught is called the over consolidation ratio. So to explain this over consolidation, so currently I'll use the same okay, we go back to the same diagram here. So we just learned how to find out sigma naught. So this is the current situation, that this is the sigma naught of that value. But the PC value, okay, that we are going to achieve through a test, actually that we achieve by odometer testing, okay, or the consolidometer test. So if in this case, what will happen, the over consolidated value, so in this case sigma C, that is the past consolidation pressure, would be greater than sigma naught. So what does that mean? Or in other words, PC is greater than P naught. Okay, so that means in the soil that we are going to do construction on, it has been loaded previously in its past, and for some reason that load has now been removed, but under that load soil has already been compressed. So to explain this, let me draw let's say if this is the clay layer and this is the sand layer. Okay, actually we should go work with the previous diagram that we are already considering. So let me drop that, sorry. Okay, I'll go back to the diagram. So this is the current situation of the sorry, let me rub it so that I have some space for working. Okay, all right, so if this is the current situation, and we learned from our consolidation test and the current calculation that our soil is a over consolidated soil. So what does that mean? That means that in the past there was an additional pressure on top of the current ground surface, okay, that can be ice or that can be some sort of soil, maybe an earthquake came or maybe a flood came that washed away all this excess load. But before we remove that load, we should remember that under this loading, okay, the soil has been compressed. So again, at the clay layer, if I want to find out sigma naught at that time when the excess load was there, so simply it would be again at the center of the clay layer. So it would be gamma of this overload into height of the overload, and then gamma S into H1, and then again here gamma C into H2 over 2. So this would be total load that will be acting on the clay layer in the past once the blue load was there. Okay, so under this load that remained there maybe for 10 years or 100 years, but under this load our soil, the clay of our interest has been consolidated or compressed under this load. Now due to some geological reasoning, maybe flood or maybe it was a glacier so it melted, whatever can be the reason, now the excess pore pressure has been dissipated. The excess load has been dissipated, but this ability of the soil to remember its memory will tell us from the pre-consolidation pressure that the soil has been loaded in its past. So it is very interesting. Okay, so this was over consolidation soil, and So this is over consolidated. Okay, now we go back. That's man. Okay. It can be there can be many reasons of over consolidation. First one is pressures due to overburden. Okay, pressure due to overburden which have been removed due to erosion or due to removal of an old structure. Okay, so there can be many reasons. So second can be that there was a glacial ice sheet which have been disappeared. So that generally happens near the mountain regions. So if this was a mountain and this was a ground surface and we had this ice cap on the top, so there was an avalanche and all this ice fell and moved around the ground and it stayed on the top. So but due to under this load, excess load, the clay layer that was here, it consolidated, and with heating over the years, in later years, this excess ice was removed or the glacier was removed, but the clay layer here has already been compressed to the load of the glacial load. And then there can be other reasons: sustained seepage forces, tectonic forces, and fluctuation of water table. All right, so it's your assignment to look at the reasons, that what can be the reasons and why they are causing the over consolidation. Okay. Now we move to the third definition, that is under consolidated soil. And when is the soil under consolidated? When this applies, that means pre-consolidation pressure is lesser than P naught. So just to jog your memories, normally consolidated clay was the case once P naught was equal to PC. Over consolidated was the one once PC was greater than P naught, and this last is under consolidated. In this case, PC is less than P naught. So you will look at the situation and you can decide that what type of soil you are dealing with, because with the type of soil, our calculation and methodologies for addressing the soil problems would become different. So 1, 2, 3. So and you see that we need PC, or the pre-consolidation pressure, to be for that soil to judge that what type of soil is this. Moving on. So this is our general E log P curve. On x-axis we have log of the stress. We have seen that in our previous lecture. So from A to C it is loading of the soil, all right, and from C to D it is unloading, and from D up to F, this portion is the reloading. Okay, so this is reloading, and then from F onward we call that as virgin compression. This portion also of from A to C is also called as virgin compression, but we see that in detail in our next slides. So the question is now how to find out pre-consolidation pressure. So as I told you before, that we will use the consolidation test to find out the pre-consolidation pressure. So you see it's a little lighter in shade. Let me zoom that for you. So this curve here, let's say A to H. Okay, so this is the pre-consolidation this is the E log P chart. This is typical of a consolidation test. Let me follow that line for you guys. Okay, so this was the curve. So what is the first step we are gonna do is that we will make a line, make a horizontal line from the maximum point of curvature of the curve. So apparently this point is the part of the curve that has maximum curvature. Make a horizontal line from A to B, make this line, all right, okay, and then draw a tangent at the same point. So this is the curve again. I'll try to make that curve exactly on the lighter shade. So we decided this point is the point of maximum curvature. We made a horizontal line, and then I'll draw a tangent to the same point. Okay, so if this is the angle alpha between the two lines, we'll draw a bisector. That means alpha by 2, and this is alpha by 2. So make this line, and the last step is, so we have this new line AD. Okay, this is the new line AD. So what we're going to do now, make a line that is tangent to the last portion of the curve, okay, or that is parallel to the last portion of the curve. So I will draw a line, okay guys, and it passes here. So where this line intersects, okay, where this line intersects the angle bisector, that was AD, that is this point here. So we move downward. So the stress here is called as the sigma C or PC, pre-consolidation pressure. Okay, so just to repeat the process again, the first step is to make a horizontal line at the okay, before that, first look at the find out the point that is having the maximum curvature on the graph. Then the second point is to make a horizontal line, okay, that is AB. And then third step is to draw a tangent to the same point of where you started the horizontal line, and then make an angle bisector. This is the fourth step. And lastly, draw a line that is parallel to the last portion of the curve, that is step 5. And then where the step 4 and step 5 are intersecting, that point is noted, and we look at the sigma value. So that value, that is the last step, is called as PC or the pre-consolidation pressure. So this is one method. Actually there are one or two more methods for finding out PC, okay. One simple method, so we just a minute, okay. Okay, so coming back, all right. So one easy method is that what should we do is that we make a E log P curve, okay. This is E, and on x-axis we have log P. So this is a general curve, okay. So this is a general curve. So one method is that simply look for the make a line that is along the initial portion of the curve, and then draw a line that is equal to the last portion of the curve where these two intersect. So that point move downward. So this point would be PC or pre-consolidation pressure. This is another method of finding out the pre-consolidation pressure from the test. So let me look if there is anything else that we need to discuss before we move forward. Okay, this actually we missed a slide here. Let me go to the presentation. This I will provide you in PDF for your perusal. Okay, so let me move down. This is one method, so we have already seen and discussed this method. All right, so this is another method. In this method, you see again we have the E log P chart. Okay, so I'm zooming that up for you. Okay, so this method in we have seen one last method is that you find out E naught, okay, for the sample, make a horizontal line, okay, and then from the last portion of the curve draw a straight line and move it upward where it intersects the E naught line. So that line, okay, can also be noted, used for finding out the PC, okay. So this can be another method to find out the pre-consolidation pressure. So there are approximately, these are the three methods that we generally adopt to estimate the pre-consolidation pressure. Okay, now the last thing relating to consolidation is, so once we have decided that what type of our soil is, then we will decide that what method do we use to calculate the settlement of that soil specimen, okay. So if the soil is normally consolidated soil, so this is a very simple formula that we will use, okay. So this is the formula for finding out settlement. So that settlement is equal to, I'll write it in more clear format. S is equal to Cc into H. H is the thickness of the clay layer, to 1 plus E naught, okay, into log of sigma naught plus, okay, the plus delta sigma over sigma naught. Okay, so delta sigma is the, because it's a normally consolidated soil, we know that sigma C is equal to sigma naught. All right, now what is delta sigma? To explain this, let us consider an example here. So because we know that sigma naught is the overburden of the soil or the self weight of the soil, and soil will only settle once there is an external load. So if this is the situation, this is the clay layer, okay, so this is the natural ground surface before we did before any construction work. So we know that at from here we can estimate sigma naught, that is gamma into H. Now we want to know that if we are going to construct a building that as an engineer you're going to design, okay, so let's say it's a big warehouse or a big industrial building, so we know that stress is going to come. So we want to know that due to this stress coming on the clay layer, let us say that the stress that is reaching at the middle of the clay layer is delta sigma. This is the increase in stress due to construction of the building. Okay, so this is what is delta sigma, or the increase in stress on the clay layer. So we want to estimate that how much settlement will occur after construction of the clay layer. So we will use this formula here. Sigma naught is the overburden pressure before any construction of the building, and delta sigma is the increase in overburden pressure due to the construction of the building. So by plugging the values we can estimate, and this H is the thickness of the clay layer for which we are interested. So we can calculate the amount of settlement, that in how much millimeter or inches the clay is going to settle, because that settlement in the clay layer would be depicted on the top. So same movement would occur on the ground, because the ground would move down due to the settling of the clay layer. Okay, so now coming to the second type of clay soil, that was over consolidated soil. So in over consolidated soil we have two cases. So just to explain this, I'll draw a E log P curve again. So this is E and this is log P. So if this is the general curve, so let's say at the time, okay, at the time once this ground was in normal condition, so let's say this was, okay, so this was P naught, all right, and we added and then we added an external load, let's say delta sigma is equal to delta P. It's your choice, either you want to represent the stress with sigma or with P, so it doesn't matter, it's just for your clearance that they mean the same thing. So I made this was the normal condition of the soil, but I constructed a building that resulted in an increase in stress. So now my stress increases PF, where PF, the final stress, is equal to P naught plus delta P. Delta P is coming from the building that I constructed. Alright, so PF is equal to P naught plus delta P, that is increase in the stress, and we call that as P final stresses. And because it's an over consolidated soil, so that means in the past it has been loaded more than the current overburden pressure. So now two situations can happen. The first situation can be that the pre-consolidation pressure falls in between P naught and PF. This is first condition, all right. And the second condition can be that our PC, or the pre-consolidation pressure, falls after PF. So our formula for calculation of settlement for over consolidated soil will depend on the location of the PC, that where PC is falling. Okay, just to explain it further in a more clear sense, okay, I'll draw that again. Let me just draw a stress bar here. Okay, so this is current situation, and this is PF, that is after loading. Okay, so first case, once the soil we are at this point now, so we are adding delta P. So if the delta P is small enough, all right, so what will happen? P naught plus delta P, so PF is equal to P naught plus delta P. So this delta P is small enough the sorry, let me correct this first. Let's say that this is PC. This is pre-consolidation pressure. We did a lab test on the sample. We know P naught from this ground situation, and we know PC, and we have calculated from our calculation work, okay, that this much delta P is going to come on the building. Okay, so now we are going to check that this delta P greater than PC or less than PC. So the first situation can be that delta P is small enough that it makes PF fall here. So this is smaller value of delta P. So in this case, we will use a settlement formula that is different than a second case. So in this case, settlement formula would be S is equal to CR into H. Sorry. Okay, just correct this here. This is not O. This is CR. Okay. Sorry. Okay, so this is CR, that is recompression index, into H is the thickness of the clay layer, over 1 plus E naught into log of P naught plus delta P over P naught. So this is the case once the delta P is small enough, okay, that means it is lesser than PC. So in this case, settlement will be calculated by this formula. Okay, and before we move further, I'll explain what CR is. It is the recompression index. Just a minute. CR is the recompression index. We'll go to the previous diagram. Okay, so we just saw the diagram here. All right. So from as I told you that from D to F the sample is reloaded because it was loaded here and then unloaded. So here this portion is reloading. As our soil has been compressed already in our past because it's over consolidated soil, so that means it's a reloading sample. So simple procedure is to make a hatch line between the two intersections. This slope is called as CR, or the recompression index. Alright, so we'll obtain CR from here, and then we will plug that in our equation that we just learned for finding out the settlement for an over consolidated soil in the case where P naught plus delta P is resulting in a PF of lesser than pre-consolidation pressure of the soil. So in the last case, where I'll draw again that this is the P naught and load is increasing from left to right, so and this is pre-consolidation pressure, and we added delta P. It's large enough, this delta P, that the PF is resulting in a greater value than PC. All right, so in this case we will have a two-part value formula for settlement calculations. So as you are familiar that this portion from P naught to PC, this is recompression, so we will use CR in this portion. Okay, this is recompression or reloading. All right, and after PC, because this is the maximum pressure the soil has bored in the past, so from onward we will have virgin compression, and we will use CC in this situation here. So writing the equation, so settlement would be equal to CR over 1 plus E naught into H, height of the thickness of the clay sample, into log of sigma, we'll make it P naught, just a minute, will be P naught plus PC over P naught, and then the second portion, that is the virgin compression, just a minute, it would be plus Cc over 1 plus E naught into H, thickness of the clay layer, into log of Pc over Pf. So whenever you are given with a numerical problem that is having a clay layer, so we will first of all look at the P naught value, and then we compare it with pre-consolidation pressure. Okay, generally in statements of numerical it is told that the soil is normally consolidated or over consolidated soil, but even if it's not written, just look at P naught and Pc value, compare them. If Pc is greater than P naught, that means we have to check for both situations, that is delta P large enough to give you a value of Pf greater than Pc, or is it small enough to give you a value lesser than Pc. So based on that, we will decide that what formula to use in case of pre-consolidating pressure. So that was it. We will try to solve numerical problems in our live sessions, or I will try to make another video for numerical solutions. Assalamu alaikum.